Well, some of these you just discovered, some of these you know, some of these I'm just going to tell you. Here we go. The derivative of sine is cosine. The derivative of cosine is negative sine. Let me give you a hint. The cos are negative. The derivative of tangent, we just found out, is secant squared. The derivative of cotangent, we just found out, is negative cosecant squared. The derivative of secant is secant times tangent, secant x times tangent x. The derivative of cosecant is negative, and then everything you just had over here. So cosecant x, cotangent x. So a couple patterns. Again, the derivative of any is negative, and they are the opposite. Opposite's the best word I can think of at the moment. They are the opposite of their other counterpart. So secant squared becomes negative cosecant squared. Secant tan becomes negative cosecant cotan. Cosine becomes negative sine. All right, the derivative of e to the x, you knew that one. That's the fun one. The derivative of natural log, we've also learned that one as well. The derivative of a to the x, so a is just some constant. It is, well, almost as easy as you think. It's a to the x, but there's a little bit of an exception. We have to multiply by the natural log of a, whatever a may happen to be. So the natural log of a times a to the x. It actually works here as well. Check this out. This is kind of neat. Watch it. If I had... let's see, the derivative of e to the x, I said y was e to the x, but I'm following this rule instead, then y prime would be the natural log of e times e to the x. So if, in this case, if a was equal to the number e, the constant e, I could do this, and then, well, natural log of e is just 1, so I'm left with e to the x. Isn't that cute? Isn't it lovely? Okay, this is kind of the same as that. There's an understood e down here in this one. So we're going to do the same thing, but we're going to have a natural log of a there. This one's kind of rare. We don't see that one very much. You'll need to memorize these.